Today we're going to start in on Chapter 6, Roots and Radical Expressions. Just a little bit of a review. Remember that the radical would be this sign. If there's no number out front, it indicates that's a 2 or the square root. That number out front would be called the index. The number underneath the radical sign would be called the radicand. And we have talked about roots before, back in the chapters on polynomials or quadratics. If you're solving polynomial equations, I may have asked you to find the roots of an equation. And that would be the same thing as if I asked you to find the solution. The root was just a value that made the equation true. So just a quick warm-up, pause the video and maybe give these 4 a try. So the first one, both of these mean the same thing. You're looking at what number cubed is 27, and that would be 3. What number cubed is negative 27? Is that possible? Sure. If your index is odd and your radicand is negative, I can certainly get out a real number answer. Negative 3 cubed is negative 27. What number to the 6th power is 64? Well, there might be two things. I mean, 2 to the 6th power is 64 and negative 2 to the 6th power is 64. But recall that the radicand is just asking for the principal root, or in this case, the positive number, where if you take it to the 6th power, you get 64. So 2 is the only solution here. On the fourth one, what number can you raise to the 6th power to get negative 64? This is a case where if I'm just looking over the real numbers, there's no real number I can raise to the 6th power to get negative 64. If I were including imaginary numbers, 2i to the 6th power would be equivalent to this. But this chapter, we're really not considering the imaginary numbers. We're kind of just looking at real numbers. Now, just some more review. Recall 5 is a square root of 25 because 5 times 5, or 5 squared, is 25. 5 is a cube root of 125 because 5 cubed is 125. And 5 is a fourth root of 625 because 5 to the 4th power is 625. So if you keep these in mind, let's look at something that comes from the book. So if you read with me, it says, if a to the nth power equals b, with a and b being real numbers and n a positive integer, then a is an nth root of b. What does that mean? Well, let's look at if n is odd. So a case like this, if I'm raising x to an odd power to get 8, if I want to look at solving this, to undo the cube, I take the cube root. So if I cube root, those would cancel each other out, and the cube root of 8 is 2. So this means that 2 is a cube root of 8. So that's kind of what this part is saying here. So 2 is a cube root of 8. If that exponent is even, things are a little trickier. So if I want to solve the second equation, take the square root of each side. Now remember, when you take the square root, you have to put that plus or minus out front. So x should equal 4 or negative 4. So that's kind of what this piece is saying. If 16 is positive, then there are going to be 2 real square roots of 16. So if I ask you for what the real square roots of 16 are, it's like saying this: what number squared are 16? There's actually 2 answers, 4 and negative 4. If I just say, what's the square root of 16? All you say is 4. The radical sign implies you're looking for the positive or the principal root. But if I'm just asking for any real roots, square roots of 16, you'd actually have 2 numbers where if you square them, you get 16. The second piece is, if b is negative, then there are no real nth roots. That's just saying that I can't square any number. I cannot square a real number to get negative 16. There'd be no real square roots of negative 16. that equation would produce the solutions 4i and negative 4i. So as I indicated in this chapter, we're only concerned about the real roots, not any imaginary ones. And in the directions in your homework on the tests and quizzes, I'll phrase things like this. So if I ask you to find the real cube roots of these numbers, that means, in other words, what numbers cubed equal the given number. That's what it means to find the real cube roots. So if I ask you to find the real cube roots of 1 over 27, I mean, you could just take the cube root of 1 over 27, or you could think of it this way: what numbers cubed give you 1 over 27? If you want to solve this equation, you take the cube root of each side. So that's really what we're asking you to do. What numbers cubed give you 1 over 27? Well, if I think about it, the cube root of 1 is 1, and the cube root of 27 is 3. So if I take 1/3 times 1/3 times 1/3, that is what would give me 1 over 27. That's the real cube root. If I take the cube root of 1,000, so what number cubed gives me negative 1,000? Is this possible? Sure. Negative 10 cubed is negative 1,000. So if my index is odd, the radicand can be positive or negative, and I should get out 1 real cube root. The last one's a little tricky. If you think of the cube root of, let's see, so this would be tenths, hundredths, thousandths, the cube root of 8 thousandths. This would be like saying then the cube root of 8 over 1,000. And kind of like we did in this first one here, if I have a fraction under the cube root, just like if you were multiplying, if you're dividing, you can take that cube root to each term separately. And the cube root of 8 is 2. 2 cubed is 8. Cube root of 1,000 is 10. So 2/10 would be your answer, or 1/5, or if you wanted to write it as 0.2. Now, if you think about it, if you cube 0.2, if you take this times itself 3 times, there's one number behind the decimal point. So if you multiply that by itself 3 times, 2 times 2 times 2, that 8 should end 3 places behind the decimal point. So that's kind of another way to think about if your answer is reasonable or not. Now, if I'm asking for an even root, be careful. So if I want the real 4th roots of these numbers, this would be like if I'm saying, what number to the 4th power is 1? Well, if I want to undo the 4th power, I would take the 4th root. And there are kind of some limitations to this. These don't quite exactly undo each other unless if the variable's positive. So this chapter, we're going to assume x is positive. If x is negative, you run into some problems here. I'll talk a little bit more about that in class. But for now, if x is positive, these would kind of undo each other. And you'd be left with the 4th root of 1. But anytime you're taking an even root, the square root, the 4th root, the 6th root, if that index is even, you have to put the plus or minus out front. So the 4th root of 1 is just 1. 1 to the 4th power is 1. But I should actually have 2 solutions here to this equation. So what are the real 4th roots of 1? Well, that would be 1 or negative 1. Because if I take either of these numbers to the 4th power, I would get out a positive 1. If you want to pause the video, give the others 2 a try, see what you come up with. So essentially, I should find 2 4th roots for both of these. It would be the real solutions to this equation. So if I solve, I take the 4th root. When I take an even root, you have to put that plus or minus out front. So here x would equal, let's see, 4th root of 16 is 2. 2 to the 4th power is 16. 4th root of 81 is 3. And plus or minus. So 2/3 to the 4th power is 16. And negative 2/3 to the 4th power is did I say 16? 16 over 81, sorry. If I take either of those to the fourth power, you should get 16 over 81. Those are the two real fourth roots. Keep in mind that this solution should have this equation should have 4 solutions because of your exponent. You'd also have 2 imaginary solutions, but right now I'm just looking at the real numbers where if I raise them to the fourth power, I get out 16 over 81. On the last example, I don't know, well, what number to the fourth power gives me a negative? This is not possible. So there would be no real fourth roots of negative 16 over 10,000. If this were a positive number, you would say, what, plus or minus 2 over 10, plus or minus 2 tenths, but can't take any real number to the fourth power and get out a negative. So the last type of example, simplify the radical expression, assume all variables are positive. Again, more on this in class about why the variables would have to be positive. Otherwise, there's some additional things we'd have to do. Think about when we did things like this. So this wasn't simplified because I could break this down into cube root of 8 times cube root of 10. And then I can actually take the cube root of 8 and say cube root of 8 is 2. And then I get my most simplified form. The same idea is happening on these types of problems. So essentially one thing to look for is if the exponent under the radical sign is greater than the index, the radical is not simplified. So if this is bigger than 3, things aren't simplified. And then we can worry about simplifying this number also. Here's one way to think about what's happening with this radical. I've just broken it apart into pieces. So I have a to the 6th power. I've broken those up into groups of 3. So I put 3 a's here, 3 a's there for a total of 6 a's. I've broken up those 9's into groups of 3. And then I can start taking the cube root. So the cube root of negative 64 is negative 4, because negative 4 cubed is negative 64. Cube root of a cubed would just be a. The cube and the cube root would undo each other. This would just be a. Cube root and cube undo each other. This would just be b. This would be b, and that would be b. So the most simplified form is negative 4a squared b cubed. Now maybe you don't want to write all of this out. There's certainly a shortcut. So think about the cube root is the same as raising something to the 1/3 power. So if I raise this to the 1/3 power, I'm taking negative 64 to the 1/3 power. I'm taking a to the 6th to the 1/3 power. If I have 2 exponents raised a power to a power, multiply them. So 6 times a third is 2. And then b to the 9th to the 1/3 power, you'd multiply your exponents, b cubed. So 3 divides into 6 twice. 3 divides into 9 3 times. So negative 4a squared b cubed. So why don't you give this one a try? I don't care which methods you use, whether you want to break the expression into the product of radicals, or if you want to use your fractional exponent, it's up to you. Choose a method and give this a shot. So here are the 2 ways to think about this problem. Man, I almost ran out of room during the first method though. If the variables are positive, the 4th root would undo the 4th power. If not, we kind of run into problems. So assuming all variables are positive, these would just kind of undo each other. So you would be left with, let's see, x times x, or x cubed. And then you'd have, what, 6y's in the numerator? And then in your denominator, 2 to the 4th power is 16. So in its simplest form, I'd get x cubed y to the 6 over 2. If you don't like writing everything out or breaking things down, you could think of this as raising everything to the 1/4 power. So x to the 12th to the 1/4, 12 times a fourth, or 12 divided by 4 would give you that 3. Y to the 24th to the 1/4, 24 divided by 4 gives you the 6. And 16 to the 1/4 is 2. So either method should give you the same answer.